Welcome to the NonFunGerbils podcast, episode 12. I'm Luke.
And I am George.
And today we speak to Peter Siemens of Dapper Labs. Peter is a software engineer and leads on client-side software and development tools for Flow, Dapper's new blockchain solution. We cover details about Flow, its structure, and how it's doing things differently. We hope you enjoy the episode.
Welcome to the NonFunGerbils podcast, the show about digitally scarce gerbils, non-fungible assets, and the growing decentralized economy. Peter, thank you so much for joining us. You work for Dapper Labs and you are one of the lead developers for the Flow blockchain. Clearly, we're very interested in everything that Dapper is doing. Obviously, Axiom then kicked off the space to a greater extent. So, you guys have seen this space kick off right from the very earliest days. And so the areas that you guys are working on now is obviously of huge interest to everyone in the NFT space. And it was really interesting for us for the whole space to see you guys decide to actually go away, build an entirely new piece of infrastructure for this area of blockchain. But before we sort of dive into the nuts and bolts of all that, tell us a bit about yourself and what your background is.
Sure. Thanks for having me, guys. This is really exciting. I'm happy to meet you guys and be on here. So I think to understand the origins of Flow and then also sort of my part in it, you have to first understand Axiom Zen and how that organization was structured and how it sort of birthed CryptoKitties and eventually Flow. So 5 years ago, I was a software engineering intern at Axiom Zen. Axiom Zen was a venture studio based in Vancouver, BC. And a lot of the work we did was client work. So we did projects for other companies that wanted to build software, but maybe didn't necessarily have the engineering team for it or the design team. But the other half of our business was sort of internal projects. So it was a mixture of work that we thought was interesting and groundbreaking in some way, or we thought could make a difference. So a typical team at Axiom Zen was maybe 2 or 3 engineers and a designer and a product thinker all working together to build something in a very short period of time. So it was lots of short sprints, quick iterations. It was very common for somebody within the company to pitch an idea, and we would say, okay, great, that sounds awesome. Let's grab 2 engineers and a designer, build a prototype, come back in 2 weeks. And we built all sorts of wild and wonderful things. And as an intern at the time, it was amazing because I could learn about all these different fields and I could sort of see how I could use software in different ways, all under this sort of umbrella of Axiom Zen. So CryptoKitties in 2017 was just another one of those projects, right? It was somebody had an idea. They said, hey, what if we put cats on the blockchain? And it wasn't as sort of serendipitous as that. It was a little bit more calculated. I think Axiom Zen had been looking at getting into the blockchain space for a while. And when Ethereum came around, suddenly there was this opportunity to build more of a user experience on top of blockchain, because that's what Axiom Zen was always good at, right? They paired like very, very good engineering with very good design and user experience and product thinking. And that was always sort of the bread and butter. So CryptoKitties was sort of just a natural fit. It was, how do we make a blockchain app that everyday people will want to use? How can we make it fun? How can we make it beautiful and interesting? So at the time, I actually wasn't there for CryptoKitties. I was still finishing up my undergrad at UBC. But I still had friends at Axiom Zen and I was talking to them. And I remember I think I texted Mac Fulbell, who is now the chief creative officer of Dapper Labs. And he said, hey, we're building this blockchain thing. It's putting cats on the blockchain. You should come back here and work. And I thought, wow, that sounds exactly like what they would be doing. I wasn't surprised at all.
Exactly what you'd been working so hard at university for.
Exactly, yeah. But it was completely on brand with all of the wild and wonderful things they were doing. So I gave them a verbal commitment to come back and work after I was done school in the following spring. And in that 6-month period, so that was, I guess, November 2017, CryptoKitties launched in December. And as you both know, it clogged the Ethereum network and then blew up, right? And then in that period of time, Dapper Labs was formed. So by the time I was done school, Axiom Zen had completely pivoted towards Dapper Labs, and even I think the day before I started working full time, I converted from an Axiom Zen to a Dapper Labs employee, and I jumped on board. And around that time, Dieter Shirley, the CTO, he emailed me and he said, "Hey Peter, do you want to build a blockchain?" And I said, "Of course I want to build a blockchain." And it was the kind of thing that we all knew was a ambitious undertaking, but I was fresh out of school and I knew the team very well. I knew what they were doing. I knew why they were doing it, and it sounded incredibly fun and exciting. So I showed up on day one ready to go. And at that point, we didn't start writing code for Flow for several months. So when I had joined, Dieter and Elaine LaFrance, who's our head of product, and Alex Henschel, who's the lead architect, had been sort of scheming and planning and architecting Flow since probably around this time in 2018. So they had a general idea of what it would look like. They had a broad definition of what the architecture would look like, but it was still very much undefined. So we spent the next 6 months or so sort of just iterating on the theoretical design of Flow and how it might work, and the idea of a split consensus compute. And during that time, I split my time between talking about Flow and drawing up designs and working with that team. And then I was also writing code for the Dapper wallet that we launched at the end of 2018 or start of 2019. Yeah, and then in February, we sort of kicked off the official Flow build. And from February to around June, we built the first prototype of Flow. It was a Python prototype. It was not meant to be performant in any way. It was just sort of meant to prove the broad overall architecture of Flow, the idea that you could have these different node roles and that they could work together and it would conceptually actually make sense. So it was basically taking what eventually became our white paper and writing it out in code. So that was done by myself and 2 other engineers on the team. And then after that was finished, we were able to show that the design was viable and it had promise. And then we hired more people and started building the real version.
Could you put Flow in context alongside maybe Ethereum in terms of its design? What was the design brief that you had that sets it apart from the blockchain that we all know and understand?
Sure. So I'll start with the way it was pitched to me was it was never pitched as an Ethereum replacement. It was pitched as a solution to the scalability problem of sort of decentralized ledger compute systems. So Dapper Labs was very excited about the idea of building these user experiences on top of Ethereum, but we were hesitant about doing that because even if we build the most popular game in the world, we would be throttled by the network throughput. And we knew that the network wouldn't be able to support it, and that wouldn't be good for the network or for us or for anyone really. We knew we wanted to keep building more CryptoKitties, but we knew we couldn't do that on the current version of Ethereum. So before we came to the decision to even build a blockchain, we looked into other layer 2 solutions. We tried to solve the scalability problem as a whole. So we didn't jump straight to let's build a blockchain. It was how can we make it possible to build massive user experiences on a blockchain network? And eventually we realized that the answer for us, for our specific use case, was to build a new layer 1 network. And the way that network was pitched to me on day one was there were certain things we wanted to preserve. So we wanted the same sort of smart contract concept as Ethereum. We wanted to be able to sort of send value, but also send arbitrary data and deploy code and have all of that. And sharding was not an option. So we had sort of made the decision early on that one of the most interesting things about CryptoKitties was the fact that you could take your CryptoKitty and you could use it in a different application, or you could sell it on a marketplace or bring it wherever you wanted to. And sort of more generally, the fact that multiple applications deployed to Ethereum can interact and in ways that are that was one of the coolest things about Ethereum in our mind. And we wanted to preserve that. So we knew that sharding was a way to get more throughput, but it was something we put at the very bottom of our list of possible solutions, if that makes sense. So we were building a non-sharded Ethereum-like blockchain, I guess. And then the third selling point was it had to be very fast. It had to have high enough throughput to support many concurrent users, and the latency had to be low enough that it could support the kinds of experiences we wanted to build, where you can send a transaction and the feedback is fast enough that it sort of unlocks these other user experiences. And then the actual design brief that has sort of been around since the early days was the idea of a split consensus compute model. So what that looks like is just the idea that you can come to agreement about the inputs, and then you can process those inputs separately from that consensus process. And what that looks like in Flow at sort of the highest level is there are two main node roles. So there's the consensus nodes, and they're the nodes that form the blocks. They use a proof of stake algorithm to come to consensus about the ordering of transactions. And if you pair that with a deterministic virtual machine, you can process those transactions. Anyone can process them and verify that the output is correct. So the other sort of broad node class is the execution node. The idea there is that they don't do any consensus. They don't do much communication. They're just very, very powerful, and they can compute many transactions very quickly. And then we sort of brought in a third node role, which was the verification node, and it would take the output of those execution nodes, split it into pieces, divide it amongst themselves, and they would verify the different chunks. So the consensus nodes would create the inputs, execution nodes would process, and then the verification nodes would actually verify that it's correct. And then along the way, we added an additional node role called a collection node, and they're kind of what I would call maybe the load balancers of the network. So they take incoming transactions from users, and they bundle them up into collections, and they feed those collections to the consensus nodes as a way of, you can think of it as sort of a batching process, where the consensus nodes then worry less about sort of communicating with the user base. There's sort of a proxy there. They just get these pre-packaged transaction collections that they then include. But at the heart of it, it was the idea that you don't need to, that not every node role needs to do all of the work. So in Bitcoin and Ethereum, every miner does everything. They do consensus, but they also do computation. So we split that up.
Was there a security trade-off in that architecture, or was that TBC, still to be confirmed?
I'm hesitant to say trade-off. There are definitely security complications. So one of the hardest parts about designing the network was figuring out how to move to this new design while also maintaining security. And so what that looks like is, I mean, we could have a whole episode dedicated to the security mechanisms of Flow, but at a broad level, it's we've taken the slashing model that's common in many proof of stake consensus algorithms, and we've expanded that to the entire network. So instead of the slashing being localized just to the consensus process, the consensus nodes have the ability, or any node has the ability to slash any other node in Flow. So if an execution node detects a verification node sort of verifying a faulty output, it can submit a challenge to the consensus nodes to slash the stake of that node.
Just so that I understand, do you need to incentivize 4 different node operators to perform to sort of, to have this infrastructure up and running, and then incentivize them to effectively check transactions that are coming in, and then I suppose rat on those that don't perform the job they're supposed to do. That seems, I don't know if that is the case, but that seems quite a lot of incentivization needs to be done there.
Yeah. So it's true that each of the 4 node roles has a sort of a different set of rules it has to follow. And incentivization plays a role in that, but we are being very careful about the kinds of incentives we give out. So, for example, each of the node roles is staked, and each node gets paid based on its stake. But the rewards we give out are, in every case, based as little as possible on sort of items of work and more on just sort of constant participation. So what that looks like in the case of, let's say, a verification node is that one of that role's duties is to verify the output of every block, right? And we could say, okay, we'll pay a verification node based on every piece of data they verify. And the problem there is that it creates the possibility for nodes to make work for themselves. And if the incentive is just to do work, it's very easy to make work.
Falls back into this proof of work kind of concept there, doesn't it?
Exactly, yeah. So we've been very wary of the situations like that. And so our incentive program, our model, is more based on just long-term participation. So if you are a verification node and you show up and you do your job for an epoch, you will get a fixed amount of money based on your stake. And same for consensus and same for execution. So the incentives do play a large role, but we're trying to be very careful of the way in which we pay them out, if that makes sense.
So what does the distribution of those different nodes look like? I mean, who is validating what?
That's a good question. Distribution as in like the sort of relative amounts of each node, or
the distribution of who are the validators? How distributed are those validators? And of the 4 different types of node, who's running what?
Right. So the model we're aiming for is to make the most important node roles as accessible as possible. So the security of the entire system sort of falls on the back of the consensus nodes. So those are the nodes that produce the blocks. They're also the nodes that resolve any slashing challenges and approve new staking requests and add nodes to the network. That is the role that requires the most participation and the lowest barrier for participation. So we hope to make consensus nodes the easiest nodes to run, and we hope to have more of those nodes than any other. And so the way that looks like with staking is we are actively trying to avoid a delegated proof of stake model right now. It's not like completely out of the cards, but it's just something we're avoiding at day one. And so the idea is that somebody can run a consensus node, hopefully on a Raspberry Pi, and be as easy as that. It won't require having a mining rig or anything like that, and it just should be very easy. And then with execution nodes, the barrier to run an execution node is much higher, but the stake is also much higher, and the punishment is a lot higher if you execute output that is incorrect. So the idea there is that if you're running an execution node, you need to sort of commit to being able to provide this much CPU power, this much processing power for this amount of time, and that requires quite a bit of buy-in. But the fact that the buy-in there is higher is okay because the validator buy-in is much lower. And then verification nodes sort of fall in between the execution and consensus nodes in terms of sort of the requirements for running them. They're not as high as, they're probably closer to the consensus side of things, but the idea there is that you would be able to sort of run a verification node on a decent home PC build. Therefore, we hope to have quite a few verification nodes as well. And the security of the network depends on there being a lot of verification nodes. It'll, like, in an ideal world, we would have a very large pool of verifiers and consensus nodes. And the staking models for both of those would be fairly similar. And then the 4th node role, which is the collector node, it has fewer attack vectors. It can't really it can't write false output to the blockchain. Its attacks are more in terms of sort of denial of service and sort of like blocking, like if you like censorship, like if you were to say I'm only accepting transactions from this person, for example. So, and the requirements to run that node are more based on storage and networking. So it's a lot of just sort of accepting many transactions and storing them for a certain period of time and making them available to other nodes in the network. So the requirements are higher than consensus and verification, and therefore the buy-in and the barrier is a bit higher, but also they have fewer attack vectors. So it's less important that there are many of those nodes.
Where's the project currently? How far along the roadmap are you? Just to sort of place all of this conversation in context, I suppose, would be good to know where things are.
Yeah. So we are weeks away from our testnet launch. So what that looks like is so back in July, we started building the Go implementation of our node software. And we have it at a point where it's running now, and we're almost ready to open up that network to the public. The plan is to run the testnet for about a month, and then follow that up with the beta mainnet. So the beta mainnet it'll be open to the public in the sense that anybody can submit transactions, but as far as running nodes go, it'll be a closed beta. So we're starting with sort of pre-approved node operators, just while we figure out the sort of lock down the software and figure out how this all performs in the wild, if that makes sense.
Are you going to be distributing a token? So what are people going to be staking when this goes live?
Yeah. So I should preface this by saying that I am not as well versed on the token economics of our blockchain, but what I can say is that it's important that we incentivize nodes from day one, and we have a token that can be used for staking. So that will be in place. On the other hand, arguably a bigger priority for us is to launch a network that has a high level of utility for users. So we will also be launching with a fiat-backed stablecoin on day one that users can use to sort of engage with the day one experiences. So the idea that we want a token that isn't used for speculation from the very start. So the staking token will, because we are launching in this sort of closed beta, we'll sort of be restricting who has access to it at the very start, but everybody will have access to the stablecoin, if that makes sense.
So the staking token isn't actually going to be used for transactional, like for purchases. It's going to be primarily the stable coin. Is that the idea there?
To be honest, I don't know the definitive answer to that right now, but I'm pretty sure that the staking token will be the token used for transaction fees and sort of all the fee payments in the system.
So I can spend this stable coin on a particular token, an NFT perhaps, but I'm paying fees I'm not paying fees in that. I'm paying fees in the underlying staking token. So as a user, I'd need to have both probably. Like I have a wallet full of stable coins and then a backup collection of these staking tokens that allows me to buy and sell and do the things I want to do with the NFTs or whatever the tokens are.
Sorry, I think I actually misspoke there. So
okay,
not quite. On day one, we actually, so for the beta mainnet launch, we actually we don't have transaction fees. We are still working on the details of the gas metering model for our VM, and the fees that are charged to users will be. We're working with the wallet providers to sort of hide that from the user on day one. It won't be the case that anyone can submit a transaction without paying. But while we figure out the details of how that token economy looks, we're just saying to users on day one, transactions are free, basically. Yeah.
Okay. And with the staking token, how you'll be giving people access to that? You'll be selling them presumably? How does that come about? How do you get those tokens into people's hands?
To be honest, we have a team working on that, but I'm not fully up to speed on the distribution plan for the staking token.
Okay.
But I do know that we are working to make it as open as possible as quickly as we can. It's just that's a tricky one for sure.
All right,
Yeah.
We might have to come back to that in the future.
Yeah, definitely.
And you're not the only project that's looking at that round the clock. I know of a few that are very much with similar issues. It was easier in a way. It was easier back in the day when you could do a fully fledged ICO in early 2017. You distributed 95% of your token, and then people sat on it for 2 years till the chain arrived, and then it's massively distributed by the time the thing gets switched on. It's much harder when you're outside of that ICO world. Well, not outside of it as such, but the way that tokens are distributed is so much more convoluted nowadays. I mean, back in those beautiful days when an address went up at a particular time and people fired their tokens in, it was a pretty heady time. But I guess those days have come to an end.
Sorry, I do wish I could give you a definitive answer on that. I've been very heads down the past few weeks working on the software that I haven't been.
Listen, don't worry. It'll be revealed in time, no doubt. So obviously, the network effects are currently obviously, well, in the NFT realm is with Ethereum. A lot of sunk cost and time and effort has gone into producing projects on there, and of course all sparked by Axiom Zen's kitties. Do you have a sense of the kind of projects that are interested in Flow to sort of begin to get that network effect moving? You kind of need a kind of traffic jam of projects that are biting your arm off to get on, I'd imagine. How's that looking in terms of the sense that you get that you're providing a tool that basically every NFT project in the world is going to want to jump on?
Right. Yeah, that's a good question. So I think in some ways that can be seen as sort of a chicken and egg problem, right? And and we're pretty confident that in our case we've removed that dilemma from the equation, mainly because half of our company right now is dedicated to building those day one experiences for users. And so that's happening internally. We're working with partners. We're working to build, like on the same day that we launch the mainnet, we're going to launch games that people can play on the network. And that's always been our focus is how do we launch something that people want to use? And that's kind of why I have fewer answers about the staking is because most of what I've been thinking about is how do we make this network as fun and usable as possible. And in addition to that, we've been engaging sort of our growing developer community on Discord and through other channels and talking to teams that are excited about either bringing their NFT projects to Flow or building new projects on Flow using the sort of the new UX patterns we unlock and things like that. So we're confident that the combination of the projects we're kickstarting internally as well as the teams we're working with externally will allow us to launch with projects on day one that are compelling and interesting for people to use.
If I'm coming across from an Ethereum-based project, what's the sort of the learning curve look like? Is there a suite of tools, dev tools that's available to me, or how does that transition look?
Yeah, I'm glad you asked. So on Tuesday afternoon, we actually open sourced the first suite of dev tools that we've built. So the plan is to eventually open source all of our code. We're still working on preparing the other repos for open source, but so on Tuesday, we open sourced a backend and a front end SDK, so Go and JavaScript. We open sourced Cadence, the language, so the reference implementation of Cadence is open to the public now. We released a Visual Studio Code extension, so basically a very primitive IDE that people can use to write Cadence, and that's paired with what we're calling the Flow emulator, which is sort of comparable to Ganache on Ethereum. So it's an emulated version of our entire network. So it exposes the same RPC interface that our real nodes will expose, and allows users to send transactions and execute code and deploy contracts just as they would on the real blockchain. So right now, a new Flow developer has more or less everything they need to start building an application. And the idea is that as soon as testnet opens up, they can take that same software that works with the emulator and flip the switch to testnet and start deploying to a real network. And then likewise, when mainnet goes live, they can just sort of point their software at mainnet instead of at testnet and move over. As far as the learning curve, we've actually been working. There is a curve, and I don't want to say it's not steep because it is, but we've been working to sort of make that curve as manageable as possible. So the first thing we released at the start of March was the Flow Playground. What that is it's very similar to sort of Remix for Ethereum, where it's a web-based IDE that people can use to learn Cadence and deploy contracts and send transactions. And it's powered by a backend that embeds the real Flow VM that lives inside our execution nodes. And the idea is that it was meant to be the tool with the lowest barriers that would allow a developer to start working with our smart contract programming language. And we have tutorials that directly use that platform, and they walk through the basics of sending a transaction and deploying contracts. And then we have a fungible token example and an NFT example. So we're basically trying to take concepts that are Ethereum or familiar to Ethereum developers, and sort of show, or sort of any blockchain developer, and show how these concepts look in Flow. And because the sort of main interface for developers on Flow is Cadence, the language, much of our early documentation is around sort of how to use Cadence and how it works and how its programming model differs from other languages and all of that. As far as transactions and accounts and signatures and key management go, there are differences there, but there are, I believe personally that stuff is easier to sort of wrap your head around. It's less of a paradigm shift than a new programming language, if that makes sense.
What's the sort of the primary use case of the network? Is it just NFTs that you're aiming at? Or is it going to be a general purpose sort of Ethereum type blockchain? Are we going to see DeFi on Flow?
Hopefully, yeah. We are definitely not trying to limit ourselves to the NFT space. The Flow has always been a general purpose blockchain. It's built to support a wide variety of applications. We hope that there are many out there that we haven't seen yet, right? We hope that it can unlock a new category of blockchain applications that nobody has seen before. But that being said, I don't think it's unfair to say that we have put an emphasis on NFTs. The fact that we have sort of maintained composability and built a programming language that more or less has built-in support for the kinds of features you need to implement NFTs, and many of the day one experiences we'll be launching with are NFT based. That's not a coincidence. That's very intentional, and it's more the fact that we see those applications as being just some of the most interesting experiences that exist right now, especially on Ethereum. And there is a large sort of community of developers that want to build those sorts of things. And sort of more, I guess, on a more philosophical note, when you try to explain what is interesting about networks like Ethereum or Flow to people who sort of outside of the blockchain world, I find at least it's often easiest, or they make the most sense when you can map these in-game these sort of on-chain experiences to real world things, right? And in many cases, that connection is something like an NFT. The idea that blockchain helps you model the concept of digital assets and digital ownership. And digital ownership is sort of, right now at least, as we understand it, it's all centered around the idea of an NFT. I personally, when I'm describing NFTs to, let's say, like my parents, I would say I wouldn't use the term NFT. I'd say, it's an asset that is digital. It's something like it's like your bike or your car, but it's digital and you can own it and you can move it around. And I think that's sort of the stepping stone from, like, people have a pretty okay time understanding conceptually what Bitcoin is, right? It's a currency that's digital. It's something you can send to people and trade, and you can buy it with USD or whatever. And I think a logical extension of that is to say, okay, well, you can trade currency online, but you can also just trade objects. Why is it any different? I sort of see that as being the next step in where this is going.
Trading is obviously a key aspect to this in many ways, especially in the NFT world. And something like OpenSea becomes a hub for this trading, and a lot of projects get integrated to it. It's becoming like the sort of almost the center of the swirling ecosystem. Do you have plans to sort of integrate with something like OpenSea, or is that possible? And also, are you looking or hoping that projects like OpenSea begin to be sort of Flow native, as it were? How do you see the marketplaces appearing?
Yeah, it's definitely possible to integrate. That's something that we obviously want to support. And as far as how we're, I guess, making that happen, our priority right now is to make the base level network as stable and as extensible as possible. And if we do that properly, then an OpenSea integration is very feasible and quite simple, and as well as any marketplace integration. We've actually been talking with the OpenSea team. They're on our Discord. I believe they are actively looking into a Flow integration. It's sort of up to them though how they approach that and how they do it. Our mandate for that team and for any team is just to give them the tools they need. We aren't actively developing a marketplace with them, but we're just giving them what they need to do it. And as far as I know, the OpenSea team is excited about that, and I look forward to seeing what they can build.
Yeah, definitely.
But we do see marketplaces as being like our one of the tutorials we launched with for the playground was how you would build a sort of a primitive marketplace with Cadence. So we see it as being something that's vital to the ecosystem, but it's not something we want to own. It's something we want the community to build for us, or not for us, build for themselves and bring to the ecosystem.
So as a user, I'm presuming that from day one, the primary interface with Flow will be through the Dapper wallet. Is that the case? And then the Dapper wallet will then support Ethereum and Flow tokens.
Yeah, that's true. So yeah, when we launch Flow, we also will be launching the Flow flavor of Dapper. I'm not sure if those wallets, like the Ethereum and Flow Dapper wallets, will be directly integrated. I think it will be the case you'll be able to use the same account for both. I'm not entirely sure what the actual UI looks like, but the idea is that yeah, you'd be able to switch back and forth fairly easily.
Okay, so it might be sort of a separate tab on within the same wallet or something like that.
Yeah, well, so the reason I'm unsure about that is because the approach we're taking for wallet integrations with Flow is quite different than what exists on Ethereum right now. The system we're working on will more or less make it the case that you don't need to have a Chrome extension to play a dApp. And we're trying to the kinds of wallets we envision on Flow are more native and as a result more secure than sort of the Web3 wallets that we use today on Ethereum. So because the underlying technology is quite different, I'm not exactly sure what that looks like in terms of consolidation, but I think ideally, like for a current Dapper wallet user, it'll be as easy as possible to have a wallet that works with both.
So if it's not plugin based, what does native mean? Does that mean having a program that runs on your computer locally, like on your machine, or does it mean something sort of JavaScript based?
So it's a bit of both. When I say native, I mean more so taking advantage of the hardware solutions that exist on our devices already. So if I were to have a Flow wallet on my iPhone or my Android phone, it would use the secure enclave on my phone rather than an in-memory key.
Okay.
And in a browser, it would use something like WebAuthn, which connects directly with the hardware on your computer. So it's sort of this. Are you guys familiar with sort of some of the latest browser-based crypto or signing functionality?
Like U2F type things?
Yeah, kind of. So like there are new browser standards for separate from blockchain and crypto. The web developers are trying to move towards a passwordless system or a world, right? Where if I have a laptop that has access to my fingerprint or some sort of secure authentication, I should be able to log in with that rather than typing in a password.
So like the titanium, the Google, Titan chip used just for authentication?
Yeah. The idea that, so more and more devices are having these dedicated hardware pieces for cryptography, right? For signing and for authentication, identity, and things like that. And the layers above that, so the browser layer and all the way to the actual web standards are exposing more and more of that underlying hardware and allowing developers to actually integrate with it. So there's a new WebAuthn standard that lets you sign into a website with if you have a Mac, you could use Touch ID, or if you have a YubiKey, you can just log in directly, and all these sort of hardware devices like that. So when we say native, we mean stuff like that. we don't want it to be the case that a user or that a wallet provider has to store private keys in browser storage, right? That's incredibly insecure and something that we see as sort of just a temporary bridge to something more secure. And the great thing is that as these standards start to mature and become more mainstream, we can build applications that sort of integrate directly with them. So if the browser has native support for signing, we can build a wallet that integrates directly with the browser rather than through an extension that integrates with the browser, right? And then there's fewer attack surfaces, there's less room for user error and things like that. So what that looks like to a dApp developer is we are rolling a lot of those features into our JavaScript SDK. So we're drawing inspiration from Web3, where Web3 sort of created this interface for more or less an Ethereum client, right? It was the idea that your browser could talk to an Ethereum client through this JavaScript library. We're taking that and instead of defining an interface for the full node client, we're saying, okay, here's an interface for a wallet. And the wallet can be implemented however you want, but it does these things. It can sign, it can create accounts, it can log you in, it can do all these things. And then the implementation isn't sort of, it's less restrictive. It can be a wallet that is completely managed by you. It could be keys that live within your laptop, and we have you run a native Mac app that exposes those or whatever, or maybe it's a fully hosted wallet on a server somewhere and all your transactions are sent to them and signed securely in an HSM somewhere and then sent back. But either way, the dApp developer is not unaware, but they are unencumbered when it comes to actually integrating with different wallets. So I'm kind of rambling, but the main goal with all of that is that if I'm a dApp developer, if I want to support a self-sovereign user who has their own keys and has their own wallet and manages all that on their own, it's the exact same as if I want to integrate with or support a user that has a fully hosted wallet.
My next question, was going to be around, how you see the future playing out, both in the NFT space, in the next few years. Like, do you think we're going to head towards, gaming over collectibles, or are they both going to thrive, or but also, flow within the context of that? What do you hope flow to become, and what do you hope the NFT space becomes over the next, 3-4 years?
So personally, I hope flow becomes the first blockchain that doesn't have to be described as a blockchain. And I'll try to explain what I mean here. I have a very difficult time explaining to my parents what I do and the kinds of things I work on, because blockchain is when you take a step back and you look at it from the eyes of the mainstream user, it's very much DeFi. It's very much based around speculation and investments and sort of these get-rich-quick schemes and unfortunately things like fraud and the sort of all the rumors of dark web money laundering and things like that. When you think of something like the internet, it's ubiquitous, right? Nobody really says the internet anymore. They just talk about the things they do on the internet, right? And I guess I want Flow to be as ubiquitous as that in my ideal world, right? Where I don't have to say, oh, Flow is a blockchain. I'll just say, oh, Flow is the thing that you use to do that. And I hope it is as general purpose and flexible enough to just make its way into everyday lives of people. And to do that, it has to be, I think it has to eventually move beyond just gaming and beyond sort of these into, I don't want to say more serious applications, but just a wider variety. And the way we see it is many great platforms were sort of introduced to the world through gaming, even the internet and things like some of the most popular day one mobile applications on the App Store and were games, right? Like many people were introduced to all of these sort of new and maybe hard to understand technologies through something inviting like a video game. And that's sort of why we are launching day one with games, because it's much easier to say, hey, look at this, it's fun, you can play with it, you can use it. And then once people see that, we can all start imagining like the broader applications that we can all come up with.
Yeah.
But yeah, I guess my main aspiration is to be able to explain it to my parents in a way that makes perfect sense to them.
Yeah, that's a great answer. I think it's all too easy to end up in our own little blockchain bubbles. When you've put the time and effort in to really scratch away at this and learn a lot about it, and you find yourself down in the rabbit hole with everyone else, you tend to just communicate with them. But to get this to get this out to a much wider audience, I think you're right. It needs to be abstracted as much as possible, and people need to be able to sort of know that there's something special going on, but at the same time, it's not too different from everything that they're used to in the sort of Web 2 world, I guess. It's just that special little something about digital scarcity and the fact that it's yours. That's the sort of the main education piece. Cool. Well, listen, it's really exciting to get the lowdown on it and to hear where you guys are with it. We will clearly be looking out for those attempts at transmitting the token to the people who need it. When more information comes out on that, we'll definitely be super interested. So yeah, thank you so much for your time. Super interesting. Great responses. Thank you so much.
Thank you guys. This has been awesome. I really appreciate the opportunity to come on. And I look forward to hopefully continuing the conversation in the future.
Great. Thanks very much, Peter.